Hello everyone, welcome back to day 18 of our SOC Analyst 100 Days Learning Challenge. Today we are diving into the world of DNS logs. So DNS logs are a gold mine when it comes to detecting malicious activity in your environment, but only if you know how to analyze them effectively. So, if you have ever wondered how hackers use DNS to exfiltrate or infiltrate network or evade detection, this video is for you. We are going to break down what DNS logs are, why they are important for detecting threats, and how you can use them to uncover suspicious activities in your network. So what we will cover in this video, what are the DNS logs, DNS logs structure, why should you care about DNS logs in a SOC, and key malicious use cases evolving DNS, analyzing DNS log, and the detection process, and few examples for the detecting DNS logs use cases. So in the bonus section, we will walk you through some Splunk practical. So we will hunt some DNS log and run some queries and then wrap it up. All right. So what are DNS logs? So let's start with the basics. DNS domain name system is like the phone book of the internet. So it translates human readable domain name like google.com into machine readable IP addresses like 142.250.72.46, the IPv4 address. So every time someone visit a website, send an email, or access a remote server, the DNS query is recorded in the log. So DNS logs are gold mine for attackers and defenders both. And what are the commonly abused DNS? So data exfiltration, command and control channel, phishing. So here you can see a DNS manager which shows the DNS details, the forwarded lookup zones, reverse lookup zones, trusted points, and the name of the DNS and what type of DNS queries are and the date. All right, so DNS log structure. So how the DNS log typically look like? So DNS log include timestamp, so the date and the time of the query. So that includes in the timestamp, and also it include the client IP address. So this is the client IP address, client IP. So the client IP address of the device making the request and the query type. So query type. So there are multiple query types like A, 4 time A, CNAME, CNAME, MX, etc. So these are the query type and domain name. So domain name is the requested name like www.google.com. Uh, then response. So the response is including IP address or other response to the DNS queries, and the TTL. So TTL is very important. So TTL is like a time to live. So the duration of the DNS record is cached. So this is how the DNS logs looks like. Next, why should you care about DNS logs in the SOC? So, DNS logs are extremely valuable for a few key reasons. Number one, the common attack vector. So, DNS is frequently used by attackers for various malicious activities like data exfiltration, command and control channels, and phishing attacks. Number two, visible traffic. So unlike other type of network, easy HTTP or SMB, DNS traffic is often allowed through firewall and rarely blocked, so making it a perfect channel for attackers to hide their malicious activities. Number three, the insight into abnormal behavior. So, by analyzing DNS logs, you can detect suspicious or anomalous activity like unusual domain being accessed, high frequency of DNS queries, or even DNS related to known malicious IPs. So, what are the key malicious use cases? involved in DNS. So before we get into the specifics of analyzing DNS logs, let's look at some common malicious use cases that make DNS a prime target for cyber criminals. So number one, the DNS tunneling, hiding exfiltrating data. So this technique involves encoding data within DNS queries and responses to bypass traditional network defenses. Number two, DGAs, the domain generation algorithm. So attackers use these algorithm to generate random domain name for command and control communication, making it harder to block the traffic. Fast flux. So attackers frequently change the IP address associated with the domain in a fast flux network, often making it challenging to track and block the malicious activity. Then the next one we have the DNS spoofing to redirecting the malicious sites. So it is also known as a DNS cache poisoning. So this attack evolves tricking a DNS resolver into returning incorrect IP addresses for a domain, potentially redirecting traffic to a malicious website. All right, so the next one is analyzing DNS log, the detection process. So the step number one, collecting DNS logs. So before you can analyze DNS logs for malicious activity, you need to ensure that your DNS logs are being properly collected and stored. So here is what you should do. Number one, ensure that logging is enabled on all the DNS servers within your environment. Collect log from internal DNS servers as well as external DNS server if applicable. Store logs in a centralized location like SIEM system, like Splunk or Elastic Stack for every query and analysis. Step number two, looking for pattern and anomalies. So when analyzing DNS log, you will want to look for pattern of legitimate activity and compare those to suspicious or anomalous pattern that could indicate a security issue. So here is what a few things to keep an eye out for. Number one, unusual domain queries. So if you notice an abnormal domain query coming from an internal system, it is red flag. Step number three, leveraging threat intelligence for detection. Using external threat intelligence can significantly improve your DNS log analysis by allowing you to correlate DNS request with known malicious domain for IP address. Many threat intelligence platforms like MISP, OTX, and Alien Vault provide up-to-date feeds of domain associated with malware campaign or command and control server. Number four, automating DNS log analysis. So, since manual analysis can be time consuming, consider automating the detection of malicious activity in DNS logs using the following methods. Create alerts. So, set up alerts in your SIEM to notify when you certain pattern are detected, like when a specific domain is queried or when TTL value are unusually low. Number two, use machine learning. So implement machine learning model that can detect anomalous DNS behavior based on the historical activity. So these models can automatically detect outliers and reduce false positive. All right, so real world use cases. So let's walk through a few real world detection use cases using DNS log. Number one, DNS tunneling. So you notice DNS queries for domain that resemble random strings. So this is often associated with DNS tunneling, a technique where attackers use DNS queries to bypass traditional network security control and exfiltrate data. So how you can detect DNS tunneling? So you can do the cross reference the domain against known DNS tunneling signatures and check for high frequency queries from the same IP. Then number two, command and control communication. So your DNS logs show queries for domain that are part of a known malware campaign like c2.server.xyz, and the compromised machine is trying to communicate with the attacker's command and control server. And how you can detect? So you can correlate the domain with threat intelligence feed and flag it as suspicious, then check for unusual outbound traffic from the client. Number three, data exfiltration. So suspicious activity, like you notice a large number of DNS queries for different subdomain under the same domain. So this could indicate that an attacker is using DNS query to exfiltrate data by encoding it into DNS traffic. And how you can detect? So look for pattern of subdomain uses that match data exfiltration technique and correlate with network traffic analysis. So in the bonus section, these are some uh, use cases. We will create SPL queries and run in the Splunk. So let's jump on the demo part. All right, so this is my demo machine, the Splunk Enterprise, and let's run some query and hunt the DNS logs. Okay, so let's hunt for baseline. So I'm going to show you all the DNS queries. So index equal to bots b1, and then source type equal to stream DNS, and then table time, source IP, destination IP, and then query type, record type, and reply code. So let's hit enter. All right, so you can see here some results. So this is going to build the baseline, who is talking to which domain. So this is good for first step before deeper detections. So you can see the time, source IP, destination IP, what query, and the record type. If any reply code comes, then we can see here. Cool, right? All right, so let's run the other query. So we are going to hunt for the top queried domain. So we are going to continue with the same indexer and source type and states count by query. Then let's do some sorting. Sort by count, and then let's limit it top 20 and enter. So this is going to identify the frequently visited domains and look for unusual high volume queries. So that could be possible beaconing or malware domains. Demo one, and so these are the queries, top queries. All right, so next one we are going to hunt for the noisy client, top source IPs. So we will use the same indexer and source type, then states count by source IP, and then sort by count, and then we are going to limit the result 10. This is going to find the machine generating excessive DNS traffic could be infected, and it is useful to spot botnets or tunneling behavior. All right, so let's hunt for some record type, the txt abuse. So the indexer and source type will be same, and we will use a filter state count by record type. All right, so this is going to find the attackers often use txt record for DNS tunneling. So too many txt record equal to red flag. So here is the result you can see. Okay, let's stop this. Next one is long domain name, the DGA hunting, the domain generation algorithm hunting. So the indexer and source type will be same, and we are going to evaluate some domain length equal to len, and then query. So if the domain length is more than 50 characters, it is going to detect that. Table time source IP query domain length. So this query can identify the malware with domain generation algorithm, the DGA one, the domain generation algorithm, which generates very long random domains, and human rarely query domains this long, right? So this can be helpful to identify the DGA. All right, so this query completed, but there is no DGA findings. All right, so let's run another query. Failed resolution, which is going to find the annex domain. So the source type and index will be same, but we are going to add some reply code here. Reply code equal to annex domain. All right, and states count by source IP and query. Source IP and query, and then sort by count. All right, so let's run the query. So this is going to identify the malware often cycles through non-existent domain until it finds an active command and control. Also, it is going to find the high NX domain ratio, which means the strong compromise indicator. Nice. So here we have some source IP and some NX domain query, and count is 1. All right, so let's run another query for the rare domains, the anomalous lookup. So source type and indexer will be same. Source type and indexer will be same, but we are going to do some states count by query. Count by query, and then the filtering part where count is less than 5. Table query count. So this is going to find the rare domain might be newly registered or malicious infra. So this query is useful for threat hunting and some kind of phishing detection. All right, so this query is taking so long, so I'm going to stop it and going to run the next query. So the next query is suspicious TLDs, the cheap domains. So let's continue with the index and source type, and I'm going to use some regex using rex, and then so you can see rex is specify a Perl regular expression named group for extract field. So I'm going to extract some field and going to use this format. So I'm going to check for the TLDs like XYZ, top, info, PW, CC, etc. And the states count by query source IP. Okay, so I have done a mistake here. Unbalanced code. Okay. TLD A to Z plus. Okay, so unbalanced code here. So this query is going to find any malicious campaign registered domain on cheap TLDs, and also it going to correlate with rare annex domain queries. So looks like we do not have any record for this. So I'm going to stop this query and going to run the another one. So the another one we have who queried a known malicious domain, and I'm going to use the query equal to star and then table time source IP. So since I don't know the target, so I have given the star, but once I have the target, I will put that query detail here. So let's find some interesting one. So this looks interesting. So this is going to pivot to find which endpoint contacted the suspicious domain, and it is core SOC investigation technique. So I'm going to use this query here. All right, so enter. So if you have any query like evil.com or something, you can put here and find out. I do not have the source IP detail, but destination detail I have here. So timestamp, query, destination IP. All right, so the final query we have is for the DNS response time. So it is going to find the possible tunneling. So let's go for it. States ABG response time as, and I'm going to sort it by max RT. Enter. So this is going to find a very high response time, which is like the possible DNS tunneling or command and control traffic. So this query compares slow versus fast queries. So you can see I have some result here. Source IP, average response time, and maximum response time. All right, so I'm going to put all these query in my GitHub repo, and you can access it. So I will provide the link in the description box. All right, so let's wrap it up. And there you have it. DNS logs are incredibly valuable resource for detecting cyber threats and anomalies within your network. So by actively analyzing your DNS logs and looking for suspicious pattern, you can uncover potential attacks like DNS tunneling, C2 communication, and data exfiltration before they escalate. Remember, DNS traffic is often sneaky and can slip past traditional security measures, but with the right analysis and tool, you can catch attackers in the act. So get comfortable with your DNS log, start monitoring for anomalies, and keep your network safe from the quiet attackers hiding in the DNS shadows. Until next time, happy detecting. So if you like the video, please like and subscribe the channel. Thank you so much.